Select the major product of the following reaction sequence. So we see that we are starting with an unsubstituted benzene, and then we have a series of 4 reactions that we are taking this through. So the way to approach this is not to be overwhelmed by the 4 reactions, but just take a deep breath and go through it one step at a time. So the first thing we should see is that we've got this methyl chloride and aluminum trichloride. These are Friedel-Crafts alkylation conditions. So we're just going to go step by step and draw the product of each of these reactions. So the methyl chloride, aluminum trichloride, this is a Friedel-Crafts alkylation. So we don't need to worry about a carbocation rearrangement because we only have 1 carbon. There's nowhere for it to go. So you're definitely going to be able to attach that methyl group to the benzene. And so this would be how we could take benzene and make toluene. Okay. And so we've added that alkyl group, and then we want to take a look at the next set of conditions. So we are reacting this with NBS peroxide, and we're heating this up. So we need to remember what NBS is. So NBS is N-bromosuccinimide. Succinimide. And so we need to remember what these reaction conditions are. And so we've got a bromine in there. Peroxide might trigger some memories as well. These are conditions for radical halogenation. And we've seen peroxide spark a lot of radical reactions. It's a good free radical initiator. And so what these conditions are specific for allylic and benzylic halogenation. So it's a way to get a bromine radical without using molecular bromine. And so we want to avoid molecular bromine with an allylic system because that has an alkene that could react with the bromine. And with a benzene ring, this is an activated ring system. It might actually brominate even without the Lewis acid catalyst. So keeping the concentration of bromine low is a good idea. So what this means is it's going to replace one of these benzylic hydrogens with a bromine. So that will be the product of this second step. Okay, so we've gone through 2 steps. And we get to the next one and we see sodium cyanide, which we should automatically read as sodium as a counter ion, which we know is going to be a spectator ion, and a cyanide ion, which is a good nucleophile. And then DMSO, dimethyl sulfoxide, is a good polar aprotic solvent. So what we have here are really good conditions for an SN2 reaction, that concerted substitution. So that's what we're going to have take place. The cyanide ion is going to react with the carbon that has the halogen, and it's going to push that off as a leaving group. And that is not a nitrogen yet. My apologies. This is a carbon. And we know that because it's the carbon that's actually attacking. So we should be forming a new bond to carbon. My apologies. Let's fix that. So this carbon is now attached to this one. So we're going to draw a carbon that has a triple bond to a nitrogen. All right, so that would be the product of this third step. And then the next thing we're going to do is we're treating this with hydrogen gas and rainy nickel. So rainy nickel is a more reactive hydrogenation catalyst, even more reactive than palladium on carbon. So this will reduce this carbon-nitrogen triple bond all the way down so that you have no pi bond left. So you're adding hydrogen completely across this so that you end up with CH2 NH2. So you've added 2 equivalents of hydrogen across that nitrile. And so this is option A. And so out of these other options, if we wanted to get additional practice, B and C are going to be beyond the scope of this class to try to make those. But what we could do is we could make D. So if we changed up this last step, if instead of doing the hydrogen gas and rainy nickel, we could recognize that a nitrile can undergo hydrolysis to get to a carboxylic acid. So you could do that hydrolysis as either H3O plus and heat, or if you wanted to heat it up in aqueous base, you could also do that, followed up with treatment with a little bit of H3O plus just to put that proton back on. So that's how we could also access D. But in this case, we are using the rainy nickel, so we're taking that nitrile and we are reducing it to the primary mean.